Hello, it's Trucker Joe, and I am here to show you guys a guide for MECS, the script that I have written and released somewhat recently. The purpose of this is just to kind of show you the basics and how to do it in a more visual way so that there's no room left for confusion. Because things like this can definitely be kind of confusing, especially since this kind of system that I've implemented is way different from what most other systems use. This basically is a motor sequencer, like that will read things like the position of servos, especially in this case, and it'll save them, including like the speed, like all the relevant settings, like where the servo is, what the speed is. And then it saves that as part of the sequence, and then when you go and run it, it checks to see the difference between the current position of the servo and the one that you have saved, and then it tries to move it there. And this is all saved per step. So I'm going to demonstrate a few of the functions, especially like in like the terms of like a bipedal walker. I'm just going to animate this leg using MECS, and I'm going to go with something kind of simple that I feel like would probably work pretty well. Okay, so the first thing you're ever going to have to do is you want to have a group. So we have these rotors, they're already named, and these are like the legs. Let's just say you are going to be servos. And the reason for this is that these are all like the different groups, so you want to name them after those. So if I recompile this, now it says I have 3 servos, it's going to list them off. That means that you've done it correctly. Anytime you want to change the names of the rotors or anything, or you change anything in the custom data, which I'll get to that later, you're going to have to recompile so that the code recognizes the change. Like, with the way it works, if a part is missing or not working, it just doesn't access the memory for it. And if you reload it, it's simply going to try to call the name, and it's not going to find the name anywhere. So it won't actually be able to access that. So we're going to want to, now that we have this group, I'm going to go and say, train, and I'm going to just say walk. And then what you should get this menu, and it's going to tell you the groups. This one will actually display the correct groups as they are named in the program. And I can also set a wait timer for each step. So yeah, actually this is going to clear that. But yeah, you can finish the training with the argument end, and you can add loop to the end of that to make the sequence loop. There is something I want to show you, and it's going to erase that, but you want the, for like a walker, you probably want to increase this tolerance number. And I'm going to actually just have it be 2 degrees. This is just like the precision with which it moves. So like it's going to wait until it comes within this. So I have it set to 2 degrees right now. And I'll remember and exit that. Also, you want to make sure precision mode is set to true. If that's turned off, then it's only going to activate every once in a while. Like it's only going to activate every what is it? Like every 1/6 of a second or a 1/10 of a rel. And what's going to happen with that is it's going to lead to somewhat jerky motion. So I'd only use that for like very stable walkers that you're not necessarily going to want to pilot yourself. I set this true so that I can like achieve higher speeds and still be precise. Anyway, all these can be changed as well. We'll just remember and exit. I need to like leave and come back because there's a problem with it scrolling. So let's go back and say train walk. So what we need to do, now that we're in this state, we want to physically get the leg to move into the position we want. Right now it's in the first stage of the animation, so I'm going to keep it. And then I want to cause it to move to the next stage, which is going to involve moving the foot and the upper rotor like this. So we're going to save that state. And so we're running it with no argument. I could, for example, do something like wait 60 and that'll tell it to wait a second, but I don't want that with this particular design. That said, you can definitely go for like smaller values, like wait 26. In precision mode, it's going to wait, like in precision mode, it'll try to be fairly accurate. If it doesn't have precision mode, then it's just going to wait for the next tick. It's going to go to 20, and then it's going to advance to like 30, and then it's going to realize that it left, like missed it. So we're just going to remove that because we don't want that. I'm going to run that second time, and as you can see, it's pretty simple now. So this kind of movement is pretty basic. Like, I'm not going to do any kind of clever thing to make it smooth yet. So now we want this, we also want this, and we want this. And now it should actually be in its final position. When it runs the script next, it's going to be in the actual like grounded position. But yeah. And then I'm going to say end. Now if I do it just end, it's going to save as a sequence that just stops. What we want here, since it's a walking animation, we want it to repeat, so we're going to say end loop. Not lube, loop. And now what should happen is, well, nothing really, but as you can see here, something appears in the custom data. So yeah, you can edit this information if you want. Like, for example, this will be like the wait time. So if you want to add like wait time to that, you can with no problem. And you can also like edit the individual fields if you know what they do. I'll probably have a guide up at some point that is going to explain all of the different components and what their custom data entries look like and how to edit them. That way you guys kind of have a better access to this kind of thing. Anyway, we have that saved, so we're going to say start walk, and that'll get it to run. As you can see here, we have a walking animation. It's pretty simple. I could increase the speed. I'd probably just do it by editing the custom data, or you could just record it at a faster speed. As you can see here, this thing is pretty, like it's got a little bit of a jerky motion, but that's alright. So we're just going to tell it to stop. Let's run stop. It's going to wait until it reaches the end of the animation. And what we want to do now, we're going to record maybe more of a quick running animation. In this particular case, I actually have to have the foot lifted. Otherwise the animation's going to go in the opposite direction I want it to. But this is like the quick, like two-step kind of animation. So let's say we want to train a different sequence, train run, and I want to increase the speed of everything by 10. So that's going to be I'm going to say 19. You're going to be 20. Actually, no, you're going to be 15. And you're going to be 14. I have this slightly slower because it kind of lags behind a little. RU is going to become 15. Now this is actually a little too fast for an actual walker, but it should work well for like demonstrating what a running animation will look like. So let's just set this up. So now, let's just train run. This is a bug. If I just press this again, it'll show the prompt again. Otherwise I could just recompile it, that also works. It won't mess with the custom data until after you end it, so yeah. And now we're going to save the first state with it being lifted. So we're going to run it like this. It says there are 4 steps because there are other steps, sequences in there. Then what we want is all of these to reverse, basically. So now it's in this position. And I'm going to run this and loop. So that's now saved. Not train run. Well, actually, if I were to do that, well, let's just look at this first. Now we have a second metadata entry, and there are 2 more entries down here. These are actually separate loops. It's defined here. Like this starts at 0 and 2, and this starts at 3 and 4. That's how it can tell. So now if I were to go train run, I could, for example, add more to this sequence. I'm not going to do that. I'm instead going to say start run. And now we have a much faster animation. From the look here, this actually, like as you can kind of tell here, this ankle is kind of slowing the mechanism down. So what I'm probably going to do is go to the foot and saying, I don't want you to wait. If I add this here, now it's moving faster because it's not waiting for the foot. Now I'd also probably change the way this foot animates because it's janky right now, and it would lead to balance issues. So I'd have to like tweak the angle of this ankle quite a bit. But yeah, by putting that in there, it stopped paying attention to where that foot was in the animation. Now if I wanted to say start walk from this animation, it would actually transition directly into that new animation. That's the power of the script, is that you can easily like transition between animations. The one issue is that they'll always start at the beginning unless you set like an offset, like start walk 2, in which case it'll start at step 2. So let's just see what happens when we set this to false, like it would be on default. As you can see, it's updating a lot more slowly, and it's moving in jerky movements. This is why I have my settings set specifically to be in precision mode. If I didn't set it to do that, if I didn't set it to precision mode, this is what you get. It would be very jerky. Not to say that isn't like a bad thing if you're going for like a particular kind of design, but like with this, it just slows it down. If I can fix this by just saying Which, by the way, yeah, this started in a weird position, but the code is able to deal with it, no problem. So yeah, that is all from me. I will see you next time.
Oh, and
Hey there.
I want to sit so I can see what I look like.